Okay, let's try another example here. And what you should clearly see is we have exponential equations. In this case, we have two exponentials set equal to each other. And before you say, oh, well, I can just set the exponents equal to each other and solve those, be careful because the bases are different. Okay, 5 and 4 are different. And I cannot write 5 and 4 as a common base. Okay, I can't break those things down into something that has the same base. So this one's going to be a little bit more involved. I can't just rewrite this as a log because I can't solve just for one of the exponential equations. What I can, however, do is a process which is called taking the log of both sides. What that means is I'm actually going to take and write a log or a natural log, either way, out in front of both sides. I'm going to use the natural log in this case, but it doesn't matter. You can use a regular log as well. It really doesn't make any difference. So what I'm going to do is I'm going to take the natural log of both sides of the equation. Okay? So hopefully what you can see there's all I've done is I've put a natural log in front of each one of these things. So this is an algebraic concept which has, it's a very old algebraic concept which basically says whatever you do to one side, you do the same thing to the other side in order to maintain the balance of the equation. So we're taking the natural log of both sides, so we're allowed to do that. What this allows me to do is use log properties now to simplify this. This is going to be a bit involved, but we'll work through it. This right here is the exponent. This right here is the exponent. Remember, one of your log properties says that if I have an exponent of my argument, I can bring the exponents to the front. And that's what we're going to do. We're going to bring those out to the front. We're basically kind of expanding this log. So let's go ahead and write that. So we'll have x minus 2 out in front. Now be careful because x minus 2 is a quantity. It's got more than one term in it. So let's put that in the parentheses. And then we've got natural log of 5 left over there. And we're going to do the same thing on the right. We're going to have 2x plus 3. But again, we're going to, plus 3. But we're going to put that in parentheses. And then we're going to have the natural log of 4. Now the ultimate goal here is to solve for x. So what I need to do is I need to distribute the natural log of 5 through everything on the left hand side, and I need to distribute the natural log of 4 to all the terms on the right hand side, because that's the only way I'm going to get those x's out of the parentheses there. So let's go ahead and do that step. So I'm going to distribute the natural log of 5 to here, and I'm going to distribute it to here. Over here, I'm going to distribute the natural log of 4 to here, and I'm going to distribute it to the 3. So let's see, we are going to get x times the natural log of 5 minus 2 times the natural log of 5. That's on the left side. On the right side, similar idea. We're going to get 2x times the natural log of 4 plus 3 times the natural log of 4. Okay, like I said, it is a bit involved, but we're getting there. Now the idea is I've got the x's out of the parentheses. Let's get all the x's to one side. It doesn't matter which one, but I'm going to get all the x's to one side. So I'm going to take this one right here. Oops, meant to do that in yellow. I'm going to take that one right there, and I'm going to subtract it to the left-hand side. So we're going to have x ln of 5 minus 2 ln of 5, and then I'm going to subtract that one, so we're going to get minus 2x ln of 4 equals 3 ln of 4, because I didn't do anything with the 3 ln of 4. Now I have all the x's on one side, but I do have one term on the left-hand side that does not have x in it, and that's this one. So I need to get it to the other side. So let's add the 2 ln of 5 to the other side. So we're going to end up with x ln of 5 minus 2x ln of 4, and then I've added the 2 ln of 5 to the right, so we get 3 ln of 4 plus 2 ln of 5. Okay? On the left-hand side now, what I have is I have all my terms with x's in it. On the right-hand side, I have no terms with no x's in it. What I can do is I see that I have an x in common in both terms. I can factor that x out to the front. So I'm going to take the x out to the front. And if I do, what that leaves us with is the ln of 5 minus, don't lose the 2 here, 2 ln of 4 equals 3 ln of 4 plus 2 ln of 5. The only step that I have left to do now in order to solve this for x is to divide everything by this on both sides. So now we're going to have that x equals 3 ln of 4 plus 2 ln of 5 over the ln of 5 minus 2 ln of 4. Okay, that is, excuse me, that is an exact answer. And if you wanted to get the decimal approximation, you simply type that in your calculator and just be very careful on typing it in. Make sure you end your parentheses after each time you do a natural log part. And I believe this was negative 6.34 as an approximation. So remember, this is exact. That is a decimal approximation of the answer. All right. Again, that's quite involved algebraically, but that is how you would solve it. Okay, we've got one more example of an exponential equation before we move on to log equations. This one is a little bit more tricky just because it's a little bit more challenging to see the form of this one. If you see something that looks like this is what you're looking for. So what I have is I have e to the 2x minus 4e to the x plus 3 equals 0. What you should see is that this one right here just has an e raised to the x. This one has an e raised to the 2x. That 2x is double the x, right? So the exponent on the first one is double the exponent on the second one, and then the last one here doesn't have an exponent at all. There's no e in it or anything. This is what's called quadratic in form. Okay, it looks like a quadratic equation. It's technically not a quadratic equation. It's still exponential, but we're going to be able to factor this just like it was a quadratic. Now I'm going to try and stay consistent with how the book here does it. And what we're going to do is we're going to make this a little bit easier. We're going to say let's let u equal e to the x. Okay, so if u equals e to the x, then u squared, if I were to square both of these, it would look like that. But remember what happens when you have a power raised to a power on the right hand side. You have e to the x squared. Well, that is the same thing if you multiply the two powers together as e to the 2x. And hopefully what you can see is that is the same as your first term. This one is the same as the middle term. So what I'm going to do is I'm just going to rewrite this in blue here as u squared, because that's the same thing here as the e to the 2x, minus 4, and then e to the x here is the same thing as what we called u, plus 3 equals 0. This hopefully now is something that you can see as just a basic quadratic. And we can factor this. So we're going to go ahead and do that. So we're going to get, if we factor this thing, it's got to be, let's see, it's got to be minus 3 and minus 1 in order for this to work. So then if I set each one of those equal to 0, I'm going to get u equals 3 or u equals 1. I did not go through the whole process there. Hopefully you can see that those are the two u values that work. Now that's great. That's solving this thing for u, but the original equation did not have u. So what I have to do is I have to plug the e to the x back in for u now. So e to the x was u, and I have to set e to the x equal to each one of those things, and now I have to solve those individually for x. Well, these are both exponential equations which now we can solve. We're going to change them into logs, and because the base is e, we're going to change them into natural logs. So the left side is going to become the natural log of 3, because that's what the right side is, has to equal the exponent, which is x. Okay, so I've solved the left one. Same idea on the right. It's the natural log, the base is e, I don't write that, of 1 has to equal the exponent, which is x. So I've now solved the one on the right hand side. So what we've got is we've got two solutions. X is the natural log of 3, or x is the natural log of 1. Now just to make sure that we see the decimal, or at least the simplified version of this, the one on the right hand side actually simplifies because the natural log of 1, so if we were to write the base e here, if I take e and I was going to raise it to some power and get 1. Hopefully you guys remember from the stuff that we did in the prior sections, the only way that you can take something, raise it to a power, and get 1 is if that something, or in this case our x, is 0. So really the natural log of 1, or any log of 1, doesn't matter what the base is 0. So really what we get is that x equals 0 on the right. The left hand side we could plug into a calculator. I'm not going to do that in this case. It's just the natural log of 3. Alright, not exactly the easiest thing. You have to recognize the quadratic in form from the top one. You can do the variable substitution if you can't figure out how to factor it without it. So do the u variable substitution there. Just remember to change it back at the end.